A ceiling fan has a diameter of the circle through the outer edges of the three blades of 120 centimeter and RPM 1500 at full speed. Consider a particle of mass 1 gram sticking at the outer end of a blade. Part 1. How much force does it experience when the fan runs at full speed? Who exerts this force on the particle? And how much force does the particle exert on the blade along its surface? So let's analyze it one by one. Here, speed is given 1500 revolution per minute. So we can find frequency, number of revolution per second. So 1500 divided by 60. So from here we can find angular speed. So angular speed is given by 2 pi f. So 2 pi into 1500 divided by 60. So 0 will cancel out. It's 25. So we get 50 pi radian per second. So this is angular speed. Now there will be centrifugal force. So radius is given. Radius is 120. This is diameter, so 120 divided by 2. So 0.6 meter. Particle is here, so there will be force. So centrifugal force and centripetal force both will be equal. So let's write it as Fc, and that is given by mr omega square or mb square upon r. In our question, mass is given as 100 grams, so 0. Sorry, mass is 1 gram. So this will be equal to 1 upon 1000 times the radius is 0.6 meter times angular speed is 50 pi. So 50 pi square. If we simplify it, so we will get 14.8 newtons. So answer to first part, how much force does it experience when the fan runs at full speed? So force experienced by 1 gram mass is 14.8 newton. And second part says who exerts this force on the particle. So this is the fan that exerts the force, and how much force does the particle exert. So to every action there will be equal and opposite reaction, so same force. Now consider next question. Question number 12. A mosquito is sitting on an LP record of a gramophone disc rotating on a turntable at 33 and 1 by 3 revolution per minute. The distance of the mosquito from the center of the disc is 10 centimeter. Show that the friction coefficient between the record and the mosquito is greater than pi squared by 81. You can take G equal to 10 meter per second square. So here information is given, so we can find frequency. So number of revolution per minute, this is 100 by 3 into 60. And angular frequency omega, sorry, angular frequency omega can be found by using formula 2 pi f, and we put the values 2 pi into f is 100 by 180. So 0 will cancel out, and from here this will cancel it 9 times. So 10 pi divided by 9 radian per second. Now radius is given as 10 centimeter, which is 0.1 meter. So force centrifugal or centripetal both will be equal, and that will be given by mr omega square. We put the values. So here r is 0.1 into omega. Omega is 10 pi by 9 whole square. So this will become m into 0.1 into 100 pi square divided by 81. So this will become m times 10 pi square by 81. Now, frictional force is given by friction. So frictional force is given by, let's write it as small fr. So fr equal to mu mg. And this force will also be same. The two forces must be equal. Only then particle will remain stick. Here it is mosquito. So mosquito will remain on the surface only when the two forces are equal. This is limiting condition, though the value of friction must be greater than this force. So we can say for limiting condition, mu mg is equal to this, or mu mg must be greater than m times 10 pi square upon 81. So m will cancel out and g is equal to 10. So g will also cancel out. Then we will be left with mu is greater than or equal to pi square by 81. Let's go to next question. Question number 13 says, a simple pendulum is suspended from the ceiling of a car, taking a turn of radius 10 meter at a speed of 36 kilometers per hour. So radius is given as 10 meter, v equal to 36 into 5 by 18. That will be 10 meter per second. And here, find the angle in degree made by the string of the pendulum with the vertical. If this is angle, if this is angle does not change during the turn, if this angle does not change during the turn. So we know while taking turn, angle will be v square rg tan theta will be given by this formula. So here our concern is to get tan theta. So tan theta is equal to v square upon rg, or theta equal to tan inverse v square upon rg. Let's put the values. Theta equal to tan inverse v square. 10 square divided by r is 10 and g is 10. So tan inverse 1, which will be 45 degrees. Now, question number 14. The bob of simple pendulum of length 1 meter has mass 100 gram and a speed of 1.4 meter per second at lowest point in its path. So let's draw the diagram. At the lowest point, center, at this point, the conditions given, its weight will be mg in downward direction, and the tension will be in upward direction, and the centrifugal force will also be in downward direction in the square upon r. So we can say tension equal to mg plus mv square upon r. So we can put the values. M is given as 100 grams, so 0.1 kg into g. G is 10 plus 0.1 into velocity square, 1.4 square divided by radius. Radius is 1. We simplify it. 1 plus 0.196. And this will be equal to 1.196 which is roughly equal to 1.2 Newton. That is our answer. Question number 15. Yes. Suppose the bob of the previous problem has a speed of 1.4 meter per second when the string makes an angle of 0.2 radian with the vertical. Find the tension at this instant. You can use cos theta equal to 1 minus theta squared by 2. So let's draw the diagram. This is situation. Now, actually, bob is here. It is making angle 0.2 radian. This is vertical line, 0.2 radian. Now, at this point, we have to check all components. So, various components will be mg will be in downward direction, and mg sine theta will pull it towards mean position, and mg cos theta will balance the tension and centrifugal force. So let's write the equation. This is tension, and in this direction, mg cos theta. This angle is again theta. Theta means 0.2 radian, and this will be mg, and this will be mg sine theta. Now, we can say tension minus mg cos theta will be equal to centripetal force, that is mv square upon r, or T equal to mv square upon r plus mg cos theta. Now, it is given that cos theta can be written as 1 minus theta square by 2. So, T equal to mv square upon r plus mg into 1 minus theta square by 2. Let's put the values. So 0.1 into speed is given 1.4, so square that out. Divided by radius is 1 meter. In previous problem, you can see here radius is 1 meter. So we write further. M is given 0.1 and G is 10, and 1 minus theta is given as 0.2 radian, so 0.2 square divided by 2. Now we simplify. This will become 0.196 plus, it will become 1. So only inside thing is to be evaluated. 2 minus 0.04 divided by 2. So this will become 0.196 plus 0.98, which can be further written as 1.17 Newton. Thank you for watching.